Hi, I'm Devansh Saxena, and today I will be discussing our paper, Are We Asking the Right Questions? Designing for Community Stakeholders Interactions with AI in Policing. This work is led by MD Romael Haque and myself under the supervision of Dr. Shion Guha at the University of Toronto. Recidivism risk prediction in the criminal justice system has garnered significant attention from HCI, critical algorithm studies, and the emerging field of human AI decision making. In this study, we focus on algorithmic crime mapping, a prevalent yet underexplored form of algorithmic decision support that is used by a large number of police departments across the United States. So here we specifically wanted to know, how do lived experiences, technical knowledge, and domain expertise shape community stakeholders' interactions with this tool? But first, let's unpack what is special about algorithmic crime mapping. It is challenging to gather community members' perspectives on algorithms used in the public sector because these tools often come with a steep learning curve in terms of how the AI works and how to make sense of counterintuitive predictions. To address these limitations, we choose algorithmic crime mapping because this tool embeds the knowledge of local neighborhoods, and the community members are innately familiar with and is centered in the city that they live in. This helps create a degree of comfort in the tool and the lab activities and helps us anchor key AI concepts. This makes algorithmic crime mapping a useful boundary object that facilitated detailed and nuanced discussions with community stakeholders about AI in policing. We conducted lab experiments and follow-up interviews with 60 participants. Participants first received an overview of the application and learned how to change the different parameters. Next, participants interacted with the application where they first identified hotspots and then placed squad cars on the map. Finally, we conducted semi-structured interviews to gauge their perspectives and needs regarding the ethical design and use of ADS. Here are our specific research questions. How do lived experiences, technical skills, and domain expertise shape people's perspectives of algorithmic decision support systems, such as algorithmic crime mapping? How do these different backgrounds translate into people's utilization of the ADS system? And what are the needs of different community stakeholders regarding the ethical design and use of ADS, such as algorithmic crime mapping? For the lab activities, the participants interacted with the following three maps in increasing level of complexity from left to right. The green circles on the top right represent the squad cars that are needed to cover the hotspots. Here are some perspectives from the participants on algorithmic crime mapping. Community members found utility in the tool, but were concerned about the motivations driving the use of such technologies by police departments. Technical participants drew attention to the vicious feedback loop that leads to over-policing of low-income and minority neighborhoods. And law enforcement shared that the tool helped them make real-time data-driven decisions based on incoming reports regarding which areas needed more patrolling. So next, we asked participants to interact with the crime maps and estimate the number of hotspots on these maps. We learned that law enforcement agents use their hyperlocal knowledge of different intersections within neighborhoods in the city to identify epicenters of criminal activity. However, in doing so, they significantly overestimated the number of hotspots. On the other hand, community members and technical participants' estimations were much closer to the optimal number of hotspots predicted by the KDE algorithm. Here, participants used their local knowledge of different neighborhoods to conceptually place the hotspots. Next, we asked participants to place the squad cars that would be needed to cover the hotspots. The goal here was to understand how they would formulate a policy for resource allocation in this context. Most community members and technical participants placed the green circles further apart and tried to maximize the area being covered such that most neighborhoods would receive some police presence. For instance, the map on the right created by a community member. Participants justified the choice by stating that they intended to deter crime by ensuring police presence. Law enforcement agents, on the other hand, placed the green circles closer together and even asked for more because 5 circles were insufficient for covering the hotspots. LEAs placed them closer together to ensure more police presence in the specialized patrol zone and to ensure the quick availability of backup for a patrol car if a situation were to arise. Here we share the participants' needs regarding the ethical design and use of algorithmic crime mapping. We learned that community members thought that algorithmic crime mapping could be a useful resource for the public to learn about the city, but wanted transparency regarding the development and use of these systems by police departments. Technical participants shared examples of how data can be tweaked and cherry-picked and need to oversee and validate crime analysis practices. Law enforcement agents drew attention to the nuances of street-level practices, where the tool only provided a high-level analysis, which needed to be followed up by street-level investigations. Here are some key takeaways and contributions. We show that community stakeholders are able to provide critical feedback on various AI life stages. Community members shared that the core motivation, that is AI problem formulation, was misaligned with the public's interest. Technical participants highlighted the elastic nature of data science practice, that is the AI development process. And law enforcement agents suggested redesign pathways to align AI with their practice and complement their domain expertise, that is AI interaction and use. In this paper, we discuss more implications for using intuitive AI applications as boundary objects and educational tools to interact with community members. We also discuss how worker-centered design of AI systems can improve practice by facilitating human AI decision-making. We refer you to the paper to look at those sections. Thank you. Please reach out to us if you have any questions. Thank you.